Namaskara, welcome to Tech Girl Kannada YouTube channel.
Second order homogeneous recurrence relation. A second order homogeneous recurrence relation is of the form Cn an plus Cn minus 1 an minus 1 plus Cn minus 2 an minus 2 equals to 0, where Cn minus 1, Cn minus 2 are the real constants. Here the auxiliary equation of 1 is given by Cn k square plus Cn minus 1k plus Cn minus 2 equals to 0. Suppose k1 and k2 are the roots of AE, that is auxiliary equation. If k1 and k2 are real and distinct, then general solution for equation 1 is given by an equals to a k1 par n plus b k2 par n, where a, b are arbitrary constants. If k1 and k2 are really real and same, a k1 par n, b k2 par n, then if they both are same, then k1 equals to k2 equals to k. Then general solution will be a plus bn into k par n. If k1 and k2 are imaginary, that is k1 is p plus iq and p minus iq, then the general solution will be an equals to r par n a cos n theta plus b sin n theta, where r equals to root of p square plus q square, theta equals to tan inverse of q by p. Solve the recurrence relation an plus an minus 1 minus 6 an minus 2 equals to 0 for every n greater than or equals to 2. That is given by a naught equals to minus 1, a1 equals to 8. Here cn equals to 1, cn minus 1 equals to 1, cn minus 2 equals to minus 6. So auxiliary equation is k square plus k minus 6 equals to 0. Since these both are different, what we have is k plus 3 into k minus 2, that is equals to 0, k equals to minus 3 and k equals to 2. The roots are real and distinct. General solution for this real and distinct is a into k1 par n, b into k2 par n. So a into minus 3 par n plus b into minus 2, just 2 for power n. So a naught is just a plus b, that is given by minus 1. A plus b is minus 1. Then a1 is minus 3 power 1 a plus 2b, that is equal to 8. So by this equation we are getting b equals to minus 1 minus a. How it has become, we have multiplied this a plus b equals to minus 1 into 2 to eliminate b. B is eliminated. Then 5a equals to minus 10, a equals to minus 2. Then b equals to minus 1 minus a, minus 1 plus 2, because minus into minus plus. Then b equals to 1. So we have general equation as an equals to 2 power n. We have that as a into minus 3 power n. So a is minus 2 into minus 3 power n, then plus b. What is b is 1, 2 power n plus 2 power n minus 2 into minus 3 power n. So we will get 2 power n minus 2 into minus 3 power n. Solve the recurrence relation Cn equals to 3 into Cn minus 1 minus 2 Cn minus 2 for n greater than or equals to 2. given that C1 is 5 and C2 is 3. So given that Cn minus 3 Cn minus 1 plus 2 Cn minus 2 equals to 0. An equals to 1, an minus 1 equals to minus 3, then an minus 2 is 2. So auxiliary equation could be an k square plus an minus 1 k plus an minus 2 equals to 0. K square minus 3k plus 2 equals to 0, then k minus 1 into k minus 2 reduced into quadratic equation. K equals to 1, k equals to 2, which is real and distinct. General solution for this is given by Cn equals to a into k1 power n plus b into then k2 power n. So n equals to 1, n equals to 1, n equals to 2. So what are we having here? C1 they have given. C1 is n, when n equals to 1, C1 equals to a plus 2b, a plus 4b, when c equals to, when n equals to 2, it is a plus 2b, 4b. Then elimination method, then it is cancelled. Minus 2b equals to 5 minus 3 is 2, so b equals to minus 1. A equals to 5 minus 2b, minus 2 minus plus 5 plus 2, that is equals to 7. General solution is Cn equals to 7 into, that is a into 1 power n and minus 1 into 2 power n. Solve the recurrence relation an plus 2 minus n plus 1 plus 2 an equals to 0. A0 equals to 1, a1 equals to 6. Given recurrence relation can be rewritten as an we should start with an minus 1 q into 3 plus 2 an minus 2 equals to 0. Cn equals to 1, Cn minus 1 equals to 3, minus 3, Cn minus 2 is 2 for every n greater than or equals to 2. So we have Cn k square plus Cn minus 1k plus Cn minus 2. K square minus 3k plus 2 equals to 0. K minus 1, k minus 2. K is 1 and 2, which are real and distinct. So that is given by n equals to a into 1 power n plus b into 2 power n. When n equals to 0, a not equals to a plus b. When n equals to 1, a1 equals to a plus 2b. A plus b is given by 1, a plus 2b is 6. So cancelling a by elimination method, we will get minus b equals to minus 5. So b equals to 5 and a equals to 1 minus b, 1 minus 5, there's minus 4. Finally the solution will be an equals to minus 4 into 1 power n plus 5 into 2 power n. Solve the recurrence relation fn plus 2 equals to fn plus 1 plus fn, where n greater than or equals to 0. And f0 is 0, f1 is 1. Given recurrence relation can be rewritten as fn minus fn plus fn minus 1 minus fn minus 2 equals to 0 for every n greater than or equals to 2. Cn equals to 1, Cn minus 1 equals to minus 1 cn minus 2 is minus 1. So k square minus k equals to 0. K square plus k minus k equals to 0. So here it is given by some imaginary number. That is 1 plus or minus root of 1 plus 5 by 2. General solution for this will be a into dot imaginary power n plus b into imaginary power n for n greater than or equals to 2. So first thing they have given as if not a plus b equals to 0, a equals to minus b. Then for this f1 they have given as 1 plus root 5 into a and minus root 5 by 2 into b. That is equal to 0 it seems. So what are we going to do now? Is there, since they have given b and b should get cancelled here. So instead of that, what will we be getting is root 5 minus root 5b equals to 1. B equals to minus 1 by root 5. A equals to 1 by root 5. 1 by root 5 and minus 1 by root 5 is the answer. Then solve the recurrence relation a n minus 6 a n minus 1 plus 9 a n minus 2 equals to n greater than or equals to 2 with a naught equals to 5, a1 equals to 12. Given that a n minus 6 a n minus 1 plus 9 a n minus 2 equals to 0, then cn equals to 1, cn minus 1 equals to minus 6, cn minus 2 equals to 9. So k square minus 6k plus 9. K square minus 6k plus 9 equals to 0. So k minus 3 whole square, k equals to 3 equals to 3. Real and same. So a plus bn into 3 power n. N equals to 0, a naught equals to a equals to 5 they have given, and for this a plus b into 3, 5 plus b into 3 will be 12. So 12 by 3 is 4, 5 plus b is 4, 4 minus 5 will be minus 1. So b equals to minus 1. So 5 minus n into 3 power n. Solve a n equals to 2 into a n minus 1, a n minus 2 minus a n minus 2 for n greater than or equals to 2. Here we will get it as a n minus 2 a n minus 1 plus 2 a n minus 2. That is given as cn is 1, cn minus 1 is minus 2, cn minus 2 is 2. Here we will get it as 2 plus or minus root 4 minus 8 by 2, that is 2 plus or minus 2i by 2. So 2 will be taken outside, 1 plus or minus I. General solution for this will be, so an equals to root 2 whole power n cos n pi by 4a plus b sin n pi by 4. N equals to 0, a naught equals to a equals to 1, n equals to 1, a1 equals to root 2 cos pi by 4 plus b sin pi by 4. That gives you root 2 into 1 by root 2 plus b by root 2 equals to 2. General solution is an equals to root 2 whole power n cos n pi by 4 plus sin n pi by 4. If a naught equals to 0, a1 equals to 1, a2 equals to 4 and a3 equals to 37. Satisfy the recurrence relation a n plus 2 plus b a n n plus 1 plus c a n equals to 0. we can rewrite the equation as, for n equals to 0 we will have a2 plus ba1 plus ca0 is equals to 0. For n equals to 1 we have a3 plus ba2 plus ca1 equals to 1. So since they have already given it as a0 is 0, a1 is 1, a2 is 4 and a3 is 37, 4 plus b equals to 0, so b equals to minus 4. Then 37 minus 16 plus c equals to c, that is equals to minus 21. The recurrence relation is n plus 2 minus 4 plus 1 minus 21 equals to 0, which can be rewritten as minus 4 minus 1 minus 21 minus 2 equals to 0, cn equals to 1, cn minus 1 equals to minus 4, cn minus 2 equals to minus 2, k square minus 4k minus 21 equals to 0, k equals to 7, k equals to minus 3, which are real and distinct. So that we will consider it as 7 power n into a plus b into minus 3 power n. N equals to 0, a naught equals to a plus b, while a plus b is 0, a equals to minus b, then b equals to minus 1 by 10, and a will be 1 by 10. That's it. So for 7a minus 3b, we are having it as 7 power n minus 3 power n by 10.
Thank you for watching. Do like, share, and subscribe to my channel.